The only announcement that I have is just, when you get a chance, if you haven't already, take a look at Canvas. Some of you, some of you are missing assignments or missing points on something that I think you should get full credit for. I just maybe need you to submit something if you didn't, or I might ask you to do a little bit more. I think in some cases you've already done it and you just haven't turned it in, but I'm not sure about that. But there are some things that I want to see that I haven't necessarily seen from everybody. The other thing is, even if you got full credit on an assignment, I may have put a comment in there, and the comment may have said something like, come and talk to me, let's check in about this, check your work. There are some things that I saw where there were mistakes. And so normally what happens on the work that I give you is that I either can't tell, because if it's a measurement, for example, I may not know. If you measured the velocity of something to be 0.3 meters per second, that seems reasonable to me. I don't know if it was actually 0.1 and you just measured wrong. I can't tell. Or it's something where I know that you got it right because I have worked with you, and we all sometimes we sort of arrived at the same answer. Like when we were doing the projectile launcher, and we eventually decided, oh hey, the initial speed is 3 meters per second, and I showed you how to do that, and we got there together. With the air cart conservation of momentum and the conservation of momentum activity, there were some of you who had wrong numbers. Your equations were wrong, your measurements were wrong, something went astray, and I don't know what it was. You can figure it out probably, and if you can, fantastic, figure it out. You don't necessarily have to check with me. But if you look at my comment and you don't understand why I made it, then I really want you to check in, because this is that skill, that mechanical skill of being able to calculate momentum for an object, being able to find the total momentum for a system of objects, to be able to find the total momentum before and after some event, to be able to evaluate your work and say, oh hey, in this particular event, I know momentum was very likely conserved, and the two numbers that I've got are off by 72%. I did something wrong. You need to have that skill, because otherwise what's going to happen is you're going to get data, and your data is going to be meaningless, and you're not going to know it. You're going to make predictions that are meaningless, and you're not going to know it because you're doing something wrong. So I really want to check in with anybody. If I made a comment, I really want to check in with you. The other announcement is AP Physics students. Again, I cannot emphasize highly enough that if you're in AP Physics, you need to be doing test preparation work outside of class. It won't happen in here. You can come and talk to me anytime. You can email me, you can ask me questions, you can work through problems, you can come in during lunch. I will work with you. I will also, as I did the other day, assign problems on AP Classroom. But the test preparation piece is its own beast. You might be killing it in this class. You might understand everything that we're doing, but you can still miss questions on the AP exam because it's all trickery. And that's the thing that you won't necessarily figure that out on your own. You can, you might be able to, and that would be great. I don't want you to assume that if you're doing really well in this class, that you're gonna ace the exam. Those are two separate things. The content, you might be solid on. The test-taking skills are really different. We're not doing that for everybody in here. So you either need to be doing it on your own, or you need to be working on it with me. And I am emphasizing this because I'm not seeing a whole lot of you, and I'm not getting a lot of emails from you, which is fine. I'm not requiring it. And if you're doing stuff on your own, if you're getting prepared on your own, I'm really happy. But I worry that maybe you're not, because if I'm not hearing anything about it, I have no evidence one way or the other. So just be aware that's really important. Okay, any questions about any of that stuff? Okay, let's talk about Impulse. And Impulse is, I think Impulse is really fun. It's super interesting for a couple of reasons. And it starts with the fact that Impulse is actually a super easy to describe quantity that ends up becoming more and more complicated as we tease it apart. one of the things that is laughable about impulse is that in physics, this term, while we can kind of see where it might come from once we talk about it, the fact that we use this we tend to use this outside of physics in a behavioral, in a psychological sense, right? Like I have the impulse to throw something at somebody because they're annoying me, or that person is impulsive. Like we know what that means. Obviously, it has nothing to do with the work that we're doing in physics, but it's interesting how we can kind of get tangled up in that. What we're going to work on today and next time I see you, which for most of you is going to be on Tuesday of next week, we're going to talk about what impulse is and how it's applied, how it's related to momentum, and then we're going to work on designing an experiment. That'll be part of today, and we'll continue working on that on Tuesday, and then we won't get started probably collecting real data. You might play around with stuff today, but we're not going to collect real data until next week. And with all of this stuff, remember what I had mentioned to you at the start of the semester, which is, it's these, how well can you, how well can you, how well can you? What I'm going to use to evaluate that are the conversations that we have. And in particular, what I'm looking for you to do is find the things that you don't understand and then talk to me about them. Come up to me and say, okay, I get this, but I don't get this. Or what if you applied this much impulse, but it was in a different direction? Or what if two objects with equal momentum bumped into each other? Is there a different amount of impulse between them? Those questions tell me two things. One, most importantly, they tell me what you already know. If you can ask an intelligent question, I can tell what you know from that. And that is super important. And then the other thing is, it tells me what I can do to help you learn more. And that is what I want this class to be all about for all of you. What I'm going to start with, I'm going to have you do some of this work because I think it'll be more interesting and more fun that way. So what I want to have you start with is to working in pairs. I don't care if it's pairs or groups of 3 or groups of 9 or whatever, but if you are just watching other people do stuff, your group size is too large. Even if it's just a pair. If there's 2 of you together and you're like watching the second hand tick on your watch and your partner is thinking about impulse, then work on your own. If you can work in a group of 5 people and all productively engage with this, knock yourself out. Here are the things I want to know. Number 1, what's the definition of impulse? You don't even need to understand it, just find the physics definition of impulse. It's not going to be a desire to do something, right? Like this is in the context of physics, objects colliding into each other. And then talk about, in your own words, what is impulse? What are the 2 quantity involves? How do they interact to affect the motion of an object? Try to come up with some sort of a anecdotal description. Like what would you do to apply impulse to an object? What happens when one object applies impulse to another one? And then the last thing is try to describe some different scenarios. And in particular, scenarios where we have like an object that's moving and it experiences impulse, but the collisions are either happen real fast or take a longer time. What does that look like? What would that look like to an observer? What would you see? Or if, and I don't want to, I mean, when we think about the word collision, it has negative connotations, but I'm thinking about like a gentle collision, right? Like if you were in a bumper car and you collided with another bumper car, totally safe. How is it that different amounts of momentum would, different lengths of time for that collision would feel different to you? What would happen to you in a bumper car if that were going on? So this is what I'd like you to think about. I'm going to give you about 5 minutes to work on this, and then we'll discuss this as a group. Okay? So. you can go ahead and get talking about that.